Okay, let's have a look at comparing the p-value to the alpha value. Students sometimes have difficulty comparing one number to another, and I know that this sounds silly, but it happens time and time again. And if you're one of those that are not a numbers person, it really helps if you take this approach. Draw yourself a number line. On that number line, put in your level of significance, which is your alpha value. In the problem we just looked at about the student debt, I think it was, we were making decisions at a 0.05 level of significance. Now, really what that 0.05 represents, as we're going to see in the notes coming up on decision errors, that 5% is a 5% chance of making the wrong decision. On the other hand, if we turn this around, there's a 95% chance that we're making the right decision. So, okay, we allow ourselves, we're only going to be comfortable. Here's what this really means. We're only going to be comfortable in rejecting the null hypothesis if there is a 5% or less chance of us making the wrong decision. And that wrong decision is rejecting the null hypothesis when we shouldn't. We calculate our p-value. That p-value is 0.128. Now, that 0.128 from a number line perspective, 0.128 is here above 0.05. Is 0.128 smaller than 0.05 or possibly could be equal to 0.05? No, the answer is no. So I fail to reject my null hypothesis. Now, what does this really mean? In setting the level of significance, which you as a researcher set yourself, you decide what level of confidence you're going to have, and of course your level of confidence determines your risk. So if we're going to make our decisions at a 95% level of confidence, there's a 5% chance we're going to get it wrong. Getting it wrong, as we're going to see, is the probability that we reject the null hypothesis when we shouldn't be doing that. Based on our p-value, right here, our p-value is 0.128. That actually means that there's a 12.8% chance that we're going to get it wrong. 12.8% chance that we're going to reject the null hypothesis when we shouldn't be doing that. And we're not comfortable with that 12.3%. It's too high. We only want to be able to reject if there's a 5 or less than 5% chance of making the wrong decision. Based on our data, there's a 12.8% chance. Therefore, the evidence is not strong enough for us to reject the null hypothesis. And in the case of this example, I think this means that the, proportion of students graduating with student debt has not changed or has not increased, since the year 2000. There's been no significant increase.